Welcome to the lecture series on soft computing in computer science. This lecture we are going to deal with intelligent optimization algorithms part 6. This presentation covers application of genetic algorithms for solving economic dispatch and unit commitment problems. What is economic dispatch? The process of determining the optimal output of multiple power generating units to meet the demand at the lowest cost while satisfying all constraints. This is called economic dispatch. Unit commitment. The scheduling of power generating units to be on or off over a certain period while minimizing the total operational cost. These problems are crucial in the operation of power systems to ensure reliable and cost effective electrical supply. So, these are the two electrical power system problems that we are going to deal, and to apply genetic algorithm for these two problems to solve or to find solution about this problem over the gradient descent methods. What is power system optimization? We are very well known that electric power system consists of multiple generating units connected to a common load demand. The primary objectives of power system operation are reliable supply of electricity, minimum operating cost, reduced fuel consumption and improved system efficiency. So, the optimization techniques are therefore used to determine the best operating condition of generators. What is economic dispatch? Economic dispatch, as I said earlier, is the process of allocating power generation among committed generating units such that the total operating cost is minimized, load demand is satisfied, generated limits are maintained. In simple terms, generate electricity at the lowest possible cost while meeting consumer demand. Need for economic dispatch. Why this ED is very important? Because of the following factors. What are those factors? Rising fuel prices, increasing power demand, environmental concerns, efficient utilization of generating stations, reduction of operational expenses. See, these are all the factors that we need economic dispatch. So, if we apply or if you develop a economic dispatch system, what are the benefits that we are going to reap? We can make benefit out of reduced fuel consumption, lower electricity production cost and improved system performance. These are the three parameters, or these are the three things we can achieve once you have implemented successfully the economic dispatch problem. So, the problem statement. See, as I said earlier, when you want to apply genetic algorithm to any problem, you need a problem statement. The problem should be mathematically stated. The mathematical stated problem should have either minimization or maximization as their objective, for which that function or the mathematical problem statement is called as a objective function. The value for the objective function that has been solved during the application of genetic algorithm is treated as fitness value. Based on the fitness value, you are trying to find another best suitable possible value by means of applying genetic operations like selection, crossover and mutation. So, this is the general procedure of applying genetic algorithm to any problem. So, for solving the economic dispatch problem, first we need to know the problem statement. So, based on the definition given for the economic dispatch problem, let us assume there are three thermal generating units are supplying power to a demand, load demand. So, the three power generating units are designated as P1, P2, P3. So, our objective is to determine the optimal generation of each unit such that the total cost is minimum and the total power generated by P1, P2 and P3 satisfies the power demand. So, this is the problem statement that we can understood from the problem of economic dispatch. So, the characteristics, that means the fuel cost characteristics. The fuel cost of a thermal generator is usually represented by a quadratic equation Fi of Pi, that is equal to Ai plus Bi Pi plus Ci Pi square. There, what is FIPI? It is nothing but fuel cost. AI is fixed cost coefficient. BI is linear coefficient. CI is quadratic coefficient. PI is power output. So, the curve is generally parabolic. So, when you draw curve for this kind of characteristics, after applying suitable values for all the necessary variables, and if you try to draw the curve for various possible values, then you can find that the curve is a parabolic curve. Objective function. So, the total fuel cost of all generator is Ft is equal to summation of I equal to 1 to n Ai plus Bi Pi plus Ci Pi square. So, here the goal is minimization of the objective function Ft. So, what is this Ft? This is total fuel cost of all the generator. So, here Pi is nothing but the generating unit. So, here I equal to 1 to n. So, here this n is taken as 3. So, we have P1, P2 and P3. So, accordingly the expansion of this formula comes. So, A1 plus B1 P1, like that the expansion goes. So, the constraint. So, what is the equality constraint? So, if you are finding a suitable value or if you are finding a feasible value, and if you are trying to apply that feasible value into the objective function and you are getting the minimal value, even then you should satisfy this constraint. What is this constraint? The summation of all Pi should meet the power demand or the system demand. That means the total generated power must equal to the load demand. So, where PD equal to system demand, so this is called power balance constraint. This constraint is called power balance constraint. Next, inequality constraint. Each generator has minimum and maximum operating limits. So, this is in general called range constraint. So, within this range limit, each power unit, each power generating unit should operate. So, it should be minimum and maximum value. These limits ensure shape operation of generators. So, these two constraints are very essential while handling the economic dispatch problem, and it has to be meticulously applied while handling the constraint. In this slide I wish to recall you the constraint handling methods. So, the constraint handling methods, you can find a lot of methods from which you can use any one of the method to solve the or to handle the constraint effectively while solving the optimization of the economic dispatch problem. So, what is in general this economic dispatch problem is generated or is stated. So, minimize the total generation cost, where minimize C is equal to summation I equal to 1 to n Ci Pi, where Ci Pi is the cost function of the ith generator and Pi is the power output of the ith generator. So, Ci Pi Ci is the cost function and Pi is the power output. So, this is what you should remember. So, what are the constraints? You have a power balance constraint and you have a generator limits. So, this is equality constraint and this is inequality constraint. What is the equality constraint? Equality constraint is otherwise called by the name power balance, where this summation I equal to 1 to n Pi equal to Pd, where Pd is the total power demand. What is the generator limits? The generator limits is between Pi min to Pi max, or that Pi min and Pi max are the minimum and maximum power output of the ith generator. So, consider an example before getting into application of GA to solve the economic dispatch problem. Let us consider a system with 3 generator. So, the cost function how it is has been expanded. C1 of P1 is 0.02 P1 square plus 2 P1 plus 50, C2 P2 0.03 plus P2 square plus 1.5 P2 plus 40, and C3 P3 is 0.01 P3 square plus 3 P3 plus 30. So, here demand is 300 megawatt. So, this is how the cost functions have been abbreviated based on the values of the system generators, right. So, to solve this problem using the gradient approach or non-gradient approach to minimize the cost function. Say for example, here the power output is given in the x-axis and the cost is given in the y-axis. So, when the power output keeps increasing, see the cost also keep increasing for every generator. So, each generator has its own characteristics curve and it shows that whenever you need a maximum power output, then the cost of the generating unit from the generator is also keep increasing. So, it is a steady increasing process. So, this is how we can try to understand the relationship between the power output that is expressed in terms of megawatt and the cost that is expressed in terms of dollars. What are the challenge in this economic dispatch? In general, any ED problem that you wish to solve practically involve so many non-linear cost functions and it has multiple constraints. Also, it shows wall point effects. More generically, it incurs transmission loss. Further, we have lot of uncertainty over the renewable energy. So, these are all the factors that you need to face while solving the economic dispatch problem. So, in order to solve this problem, even though we have lot of conventional optimization methods, because of these practical complexities, the conventional optimization methods get struggle or it is not been effectively applied to find the solution to the economic dispatch problem. So, what are the conventional methods? The conventional methods are otherwise called by the name traditional methods are lambda iteration method, gradient method, Newton-Raphson method and linear programming method. So, these are all the methods that can be used. So, again I am saying that these methods are gradient based method or derivative method where you have to calculate derivative by derivative at one point of time you need to stop the process. Whereas, the algorithm that what we are going to discuss in this intelligent optimization algorithm is genetic algorithm. It is a gradient free, that means non-gradient search method and derivative free methods. When you apply this traditional ED methods, even though you got some good solutions, the limitations also we are facing on the other side. So, what are the limitations? So, the first and foremost limitation is the traditional method may get stuck in the local optimum, because if you try to solve the economic dispatch problem and if you find the solution curve of this economic dispatch problem, it contains a lot of modes. So many modes are there, see, so many modes are there, like this, it has so many modes. So, when your system is find this as a best solution, but this is a local minima and you have lot more local minima here, but this is going to be the overall global minima. So, if you want to reach this point or if your searching is trying to reach this point, you cannot reach this point because your solution already gets stuck in that location. So, this is what may get located in the local minima and it requires derivative functions. See, first order derivative, second order derivative, like that it requires a derivative because it is a derivative based methods and it is difficult to solve these derivatives. And finally, when you have any non-linear constraint, then the traditional methods are failing to handle or it is feeling very difficult to handle the non-linear constraints. So, these are all the weakness with conventional methods. What are the working principles of genetic algorithm? What are the working principles? Population initialization, fitness evaluation, selection, crossover, mutation, replacement, termination. So, these are all the points that we need to take care of while applying the genetic algorithm to understand the various working principles of GA. So, population initialization, fitness evaluation, selection, mutation, crossover and termination. So, that you should need to follow that. How to represent the chromosome? In general, if you take an example of a 3 generator system. So, for a 3 generator system, if you want to represent the chromosome, there are 3 power generating units P1, P2, P3. So, this P1 and P2, P3 are represented in the form 350, 250, 250. So, Here each chromosome, this is one chromosome, maybe another chromosome 325, 240, 230 like that, another chromosome maybe 310, 220, 250 like that, another chromosome maybe 305, 215, 225 like that. So these are all the various chromosomes, right, and each chromosome represents one possible operating condition or operating solution, P1, this P2, this P3, and you need to take these value and substitute in the equation in order to find out the objective function value, right. See, these are the possible. So, randomly generated power outputs within the generated limits. So, this you should know, within the generated limits, because this is the inequality constraint and it specifies the range of the power generating unit, right. So, this is the first chromosome, that is second chromosome. So, this is the initial. So, now can you guess what type of genetic algorithm it is if the population initialization is like this? So, it is the real coded genetic algorithm, it is not a binary number represented chromosome, it is a real. So, actual values are represented within the generating limits. So, this is the idea. Next, fitness function. So, the fitness function evaluates the solution quality. So, when you want to evaluate the randomly generated chromosome where each chromosome is treated as the solution for the problem, if you want to test the solution fitness, then you should be evaluated very properly. So, for an economic dispatch problem, fitness is nothing but total fuel cost. Whenever this total fuel cost is lower, as much lower possible, it means that fitness is better as possible. So, the chromosome with the minimum cost is preferred always. So, this is treated as fitness value. So, our objective is to calculate the function. That function involves power generating units. The power generating units values are randomly generated and each randomly generated set is called chromosome, and that chromosome it has to be applied over the objective function and it will give you the total cost, and we are always trying to look for the lower total cost. The chromosome which is giving out the lower total cost is the one which is showing the minimum cost, and it is the most preferred one to the successive generations, or it is the one that gives the minimum possible expected value, or it is treated as the optimal value. So, once the fitness function is evaluated, we are very well known that the genetic algorithm will try to apply operations in order to focusedly generate. See, in the initial stage, all the decision variable values are randomly generated. Now, there should be a guiding factor. That guiding factor should generate or should remodify the initially randomly solution variable towards the optimal locations. So, for which we need to apply genetic operations like selection, crossover and mutation. For what about for particle swarm? If I apply particle swarm optimization, what is needed? Velocity and position updation. If you apply ant bee colony optimization, what do you apply? Applied bee phase, onlooker phase, scout bee phase. All these three phases you should apply, and based on that you will try to get the new possible values. Here we do not discuss about ACO algorithm, because ACO algorithm is a combinatorial optimization problem, but this problem is a real number optimization problem. So, we no need to discuss about ACO here. So, let us take the idea of genetic algorithm. So, what is the selection process in genetic algorithm? Selection is the task that chooses the best chromosome for reproduction. So, the next step we want to do is giving more opportunity to good number of individuals, and that task is treated as the reproduction. For better reproduction, you need to choose the best chromosomes. So, what is mean by best chromosome? Best chromosomes are the one which is giving best optimal value. So, what are the popular methods? Rowlett wheel selection method, tournament selection method, rank selection method. So, these are all the popular methods that can be used to conduct the selection process. So, what is the purpose of the selection process? We want to retain some good solutions. We need to safeguard that good solutions. We need to try to produce as much as good solution from the good solutions. In doing so, we did not lose the good solution and get stuck into the poor solution. So, the selection process will always try to select good individuals, or good, it always try to retain the good solution. crossover operation. So while to apply crossover operation, we need two chromosomes. There are two parent chromosomes that exchange the informations. Let us take, right. So one parent is this, another parent is this. Now we have two parents, parent 1 and parent 2. So in order to produce a chromosome, that means in order to produce an offspring from these two parent, we need to cross the value. See what is how the values are crossed. Here 350 is there, the 350 is taken here. Instead of this 200, this 200 is going there and this 50 coming there. So we get a new offspring with the new possible value. Maybe for this operating conditions, in this offspring, P1 is 350 and P2 is 200 and P3 is 250. So now you got a different combination, right. So based on this different combination, if you evaluate the objective function, you got a different value. So at crossover operation, always try to produce new solutions. A new solution may either good at producing the optimal value or may go with some poor optimal value. So accordingly, we need to conduct the idea. Right. Next operation is, as you are aware of it, it is sudden change of any randomly selected chromosome. That means you need to apply some random changes, and the random changes is equivalent to mutation in the evolutionary process. Hence it gets the name mutation operation. So what is the purpose of this mutation operation? If you want to maintain diversity, because when you are keep applying selection and crossover, your search will be only localized towards the certain things. As I said, the mutation operation is very effective, then only your algorithm will try to escape from the local minima and try to always to find the good optimal value. So when you want to apply or when you want to maintain diversity of the explored solutions, then mutation operation is the very essential one. Also it avoids the local minima, as I said, right. It try the search process to come out of the local process, right. And exploration, it tries to explore all the possible values. Wherever some possible values are needed or wherever some new locations has to be explored, this mutation operation will be very helpful. So selection, crossover, mutation, all these three operations are repeatedly applied over the process, and ultimately we come with the very good, ideal and optimal solution for the economic dispatch problem. We will discuss in detail about the MATLAB implementation of this economic dispatch problem in the MATLAB session. Next kind of application of genetic algorithm to the power system optimization problem. What is this power system optimization problem? That is unit commitment problem. What is this unit commitment? Before understanding what is this unit commitment, let us understand or let us have a glance at what is a power system. A power system is one that consists of multiple power generating units operating simultaneously. So when you get into a power system, right, you can find lot of power generating units and all power generating units are operating simultaneously, right. In that case, if you are an operator of a power system, then you should know, instead of operating or instead of utilizing all the power generating units simultaneously, it is essential to think which unit should operate and which unit should remain shut down, because we are wasting the fuel, right. So and how much power should each unit generate? We need to have a meticulous idea about all these kind of stuff, right. So this kind of problem that looks for what kind of unit should operate and what should remain shut down and how much power should be generated. So this kind of problem statement is called unit commitment. So what is unit commitment? That is literally defined is the process of determining on off status, which power unit should off, which power unit should get on, status of generating units over a scheduling horizon while minimizing the total operating horizon. So our objective is to minimize the total operating cost, but we need to think about the scheduling horizon. So the scheduling horizon is very essential and we need to explore the on off status of the power generating units. So the power generating units meet the load demand, maintain reserve requirements, minimize operational cost. So these three things that you need to think about while understanding the problem of unit commitment. So the unit commitment is the process of determining on off status of generating units over a scheduling horizon while minimizing the total operating cost. So, this is what unit commitment. So, need for unit commitment. You are very well known about that the power demand changes hourly. On an hourly basis, if you look at the change in power demand, it is changed for every hour. So, operating all generator continuously is expensive. See, this is the situation, right? When you want to operate generator at all the situations and keep on operating the power generator continuously, definitely it is an expensive process. And so, it is very essential to look for which are the generator that are needed, which are the generator that are very highly committed to proceed with. So, we need, let us take an example, let us take a time and a demand. We all know that at midnight the power requirement is very low. At morning also the power requirement is medium, at the evening the power requirement is high. So, it means that at the evening time, since the power requirement is very high, you have to operate all the power generating units, whereas in the midnight time certain power units may go shut down because of the expensive process while operating all the generator and to reduce the power generated process. What is the difference between this EUD and unit commitment? See, the economic dispatch is focusing on the generator outputs, whereas the on off status of the generator. Once the generator is on, how much output is producing? See, how much power that generated is economically dispatching in the transmission line. So, that is what economic dispatch. How much commitment a power generating unit is playing in the overall system of power system, it is unit commitment. So, accordingly the name has to be given. And if you look at the objective function, this economic dispatch problem is a continuous optimization problem. The variable values are continuous in nature, or sometimes if you take this, it is a whole number, means it is integer nature. But when you come to unit commitment problem, it is surely a mixed integer optimization problem. On the other hand, when you take the economic dispatch problem, it has a mixed committed units, whereas for unit commitment problem, it has a variable committed units. So, it is very easier to solve and it is little bit complicated to solve the problem. Objectives of unit commitment and total operating cost. The unit commitment problem aims to, as I said earlier, to minimize the fuel cost, minimize the startup cost, minimize the shutdown cost, maintain reliability, safety. So, these two things are qualitative objective and these three things are quantitative objective. So, in general, for defining the mathematical function for the unit commitment problem, the total operating cost will involve fuel cost, startup cost, shutdown cost, and this cost should be minimized. So, this is the objective of the function. So, the fuel cost function, is what we have seen in the economic dispatch problem. The same cost function here also applies. And what is the cost function? The startup cost as well as the off cost, that means on and off cost. So, it has two values, one is hot start cost and a cold start cost. So, it is the generator has been recently shut down and once you are turning on, so how much cost it is addressed. The generator is long time it has been shut down, and what is the generator cost? What is shutdown cost? For off conditions, right? So, if the generator is off, and what is the cost associated with when it is on? When you are going to on, recently shut down or shut down for a long duration. So, both has a difference. If it is recently shut down, then the startup cost is very minimum, it has been easily started, whereas it is shut down for a long duration, to start that it needs more amount of time. So, that you think you should remember. So, shutdown cost, that is cooling expenses, maintenance cost, operational losses, all comes under shutdown cost. So, this is what the total cost when you try to solve the unit commitment problem. So, this is mathematically stated, the function, the number of generators, scheduling period and the unit cost, and each generator has a thing UIT and UIT 0 or 1. This makes a mixed integer problem. So, if it is a binary decision problem, each generator has a two states and our objective is to minimize. So, minimize the given objective function. So, this is what the unit commitment problem that has been mathematically stated. So, this is another version of how the unit commitment problem has been mathematically stated. It is the expanded version of the various factors involved in it, that is operating cost C is minimized, that has been based on fuel cost plus shutdown cost plus startup cost. So that you need to understand that. So what are the constraints? So it is also a constraint based problem. So the constraints are, one is power balance constraint, another one is generated limit, that is a range constraint, another one is the minimum up and down time. So between these time of constraint that you need to do it. So these are all the constraints. So these constraints should be effectively handled according to the constraint handling method that has been discussed. So in order to further understand that, see, let us take an example. If you want to consider a system, if you want to apply the idea about unique computer problem, let us consider a system with a cheat generator and it has been executing and running over the 24-hour period. So what is the demand profile? The demand profile is represented in terms of megawatt. It is 400, 380, 360, etc., 420. So for each demand profile, you have a startup cost S1, S2, S3, right? So now the chromosome representation is 3 generated, right? So here this 1 represent the generated 1 is on, 0 representation generated 2 is off, and 1. So these are the combinations 101 and 001 or 110 or 1111 all the. So this is, if you apply on for all the chromosome generator, if you apply off for all the generator, so it's like that. So for each things you may treat this as a schedule. This is one schedule, this is another schedule, this is another schedule. So this schedule is 1, 2, 3. That means all the 3 generators are in on condition, and this is 0, 2, 3, and this is another combination is 1, 0, 3. So this is the combination numbers schedule. That means first generator is on, second generator is on, and the third generator is on. Here the first generator is off, the second generator is on, third generator is on. So like that. So this is has been treated as the initialization of the population, and it has been initialized randomly. So after population initialization, you very well know that each chromosome is applied to the fitness function, the fitness is evaluated, and everything has been executed. Based on that, the best fitness value has been applied. So if you apply the non-gradient methods or like this genetic algorithm to find the optimal schedule is like this. See, if in case of hour in the x-axis and power demand in the y-axis, the 24-hour power demand profile is like this. So like this, you can find solution to the unit commitment problem. So further detail to solve the unit commitment problem and its associated MATLAB code can be seen in the practical session. So the fundamental difference between these economic dispatch and see, when you come to the gradient descent, you can always feel that it is fast and efficient, but it is sensitive to the learning rate. But when you come to genetic algorithms and all, see, you can solve this complex problem even if it is the constraint is complex. So likewise for another algorithm similarly, you can find these kind of experiences when you try to develop code in MATLAB or Python to solve these kind of problems either using the gradient descent method or a non-gradient based method like genetic algorithm and simulated annealing. So with this we come to the end of the session that discusses about how economic dispatch problems and unit commitment problems are understood and has been very well established to solve the same using genetic algorithm. Thank you.